So now we're going to do a few more problems from section 7.5. Now what we're going to do first here is take a look at these two here. I want you to see something here. So keep in mind, we talk about inverse functions. Right here, we plug in a ratio and we get out an angle measure. So this is going to be an alpha. And this here I'm going to call beta. So what we're going to do is we're just going to set up two triangles for these. Now when I do tan inverse either lives in the first or fourth quadrant. But since that ratio there is positive for tangent, it's going to put it in the first quadrant. And I know tangent of theta equals opposite over adjacent. So that means that 4 is going to go here on the opposite side. And then the 3 is going to go on the bottom because that's the adjacent side. And then this here, using the Pythagorean theorem, is going to get me 5. Okay, and I'm just going to call that alpha. Then I'm going to do the same thing for the cosine inverse. And that's just going to be a different angle here. And that ratio is also positive, so that puts me in the first. And I know cosine of theta, or cosine inverse of a ratio, is going to be either in the first or second quadrant. And cosine of theta equals adjacent, so that 5 is going to go on the bottom side because that's my adjacent. Hypotenuse is 13. And using the Pythagorean theorem, we know this opposite side is going to be 12. And we're going to call that our beta angle. So that's where this alpha and beta comes from. So really, essentially what we have now is this is actually equal to the cosine of alpha plus beta. And essentially we're just going to use that formula now. Okay, so that's going to be cosine of alpha, cosine of beta. We're using this first one here. And then minus sine of alpha, sine of beta. And if we think about what those values are, now the cosine of alpha, we're coming back here to this first angle, and cosine is adjacent over hypotenuse. So that's going to equal 3/5. And the cosine of beta, using the second one now, that's going to be 5 over 13. And I got a minus here. And the sine of alpha is going to be 4/5. And the sine of beta is going to be 12/13. And when I put that all together, meaning I'm going to multiply straight across for fractions, that's going to be 15 over 60. Oh, let me erase that. That looks like a terrible 5. Okay, and that's minus, and that's going to be 48 over 60. And when I subtract those, that's going to give me a negative 33 over 60. And when I reduce that, that's going to be a negative 11 over 20. So there's our answer, our exact answer for those conditions for that problem. Now let's try another type of problem here. So moving over, this says establish the identity. So what we're going to do here is we're going to actually start from one side using algebra, substitution, and trig identities to make it look like the other side. Now I'm going to pick the more complicated side, meaning I'm going to pick this side here. And what I'm going to do is I'm first going to turn it into all sines and cosines and eventually get to cotangent of alpha plus beta. All right, so now take a look at how I set this all up. I did all sines and cosines here for cotangents. So as you can see, I set it up below. And if you need to stop the video or pause it, do it at any time to actually go through it and make sure you're okay with this. So now what we're going to do is we're actually going to subtract the tops together. So in order to do that, and add the tops together, I should say here. So this right here is a plus, so I'm going to have to add that. So what I'm going to do is I'm going to put a 1 under there. And what am I going to have to do with this? I have to make it like denominators. So I'm going to multiply both the top and the bottom by the sine of alpha, sine of beta, and the sine of alpha, sine of beta. Because keep in mind here that this is just multiplication here, and I'm just multiply straight across. So that's just one term in a sense that you can look at. And on the bottom here, this one here, I'm going to have to multiply by the sine of alpha. So I multiply the top by the sine of alpha. This one I'll multiply by the sine of beta, so I multiply the top by the sine of beta. Oops. So now I'm going to show you what that looks like. Now take a look how that turned out. Looks pretty nice, right? Very complicated looking. Now what we're going to simply do here is just add the tops. And what I mean by that is I'm going to take this plus this and write it over the same denominator. And I'm also going to do the same thing with the bottom. So you see what that looks like in a second. So now take a look at what we have here. So now from here, after I added those tops together, just like I told you a minute ago, over the same denominator, I did that for both the top and the bottom. Now think of it this way. This right here means divide, right? That means divide there. So I usually, when I divide with a fraction, I take the top times the flip of the bottom. And that's what we're going to see next. And this is what we end up with below here. So now what we're going to do is we're going to actually just multiply these. But keep in mind here, when I'm multiplying, I can cancel top to bottom. So when those cancel out, they leave ones in its place. So now think about this. I'm just going to multiply straight across now. And this is what I end up with. Now notice what we end up with here. And if I take a look at the top, what I'll notice is this one here, this plus here, cosine of alpha plus beta, times cosine of beta. That's going to be right here. And then if I look at the sine of alpha times the cos of beta, that's this one down here. So I actually end up with cosine of alpha minus beta over sine of alpha minus beta. And this actually equals cotangent of alpha minus beta. And I just noticed something as I wrote this down. You guys might get a kick out of this too, that when I originally wrote this problem out, notice here, I had a plus there. That should not be a plus. That should actually be a minus. So I hate doing that here because I hopefully that didn't confuse you too much. So I'm just going to erase it, and then I'm going to put a minus there. It should have been a minus to begin with, so fix your paper. Okay, so there's our answer, and we've seen how we got from one end. So again, we started from here on the right side here, the more complicated side, did all of this algebra and trig identities and got down to the other side. And that's what you see on the left side here. So that's really the basic idea of any of these. Start from one side using algebra identities, make it look like the other side. So there it is. There's our answer.